All right then. So let's jump right into the topic at hand here. So this meeting basically is where we actually discuss, some of the features, some of the upcoming item topic that associate with the operator lifecycle manager project specifically. And it seems like we're having two topics today. And I think the first topic will belong to Chris Johnson about quite a few things here. So I guess we will start with that. And after that, myself will having a quick discussion as well about the cluster runtime constraint proposal. And I linked it, the enhancement there as well, if anyone wants to take a look in the meantime. All right, so let's get started with Chris and his proposal. Chris?
Hey, thanks. Can you hear me okay?
Yes.
Good. This is a new Mac, well, new old Mac, and first time using Zoom on it. Okay, so let me share my screen. Do that. So this is kind of a pre-proposal. So I didn't want to submit an EP for this yet until I just kind of I wanted to bounce this off you guys a little bit first. So we've talked a little bit about optional dependencies a few times over the past couple of years, or at least the last year. We have actually developed our own way of our own operator called the Operand Deployment Lifecycle Manager, whose real purpose was to manage the lifecycle of the operands, so the CRs, to make sure you could have shareable resources and things like that. So we basically have one operator called the foundational services operator, which is I think some people call it an umbrella operator, meta operator, and that has the ability to declare what kind of operands you want to have, and it basically has a resource counter and things like that to make sure you don't have a bunch of these things running. But one of the side effects is it actually can create subscriptions for other OLM operators as they're needed. So as I'm trying to come up with a way, I wanted to come up with a way to take pieces of that concept and see if we can make it a first-class citizen of OLM. So how can we describe operator dependencies in such a way that they could be used by various clients? So you use an operator developer could describe your intent for what this dependency means, and then from various clients be able to do something with that intent, right? So right now, so what I did is I looked at a bunch of these different package management systems, and I'm sure I know you guys a lot are aware of all of these, and there's probably a lot of more other ones I could take a look at, and tried to understand how they used optional dependencies, how they define them in here. And there's really, and the reasons for having optional and recommended and suggested dependencies really vary greatly. So I really wanted to boil it down to a couple basic use cases and then allow clients to kind of figure out what they want to do with that information. But at minimum, at least influence what OLM is going to do. So OLM uses the dependencies, in my mind anyway, for really two things. One, make sure that an operator, when it installs, it has its prerequisites there, right? So its dependencies are already there, but it also does provisioning for you. So it behaves a lot like Homebrew does. So Homebrew has a required dependency. They also have build and prereq dependencies. I'm sorry, down here. And Homebrew has required dependencies, and then it has what are called optional and recommended dependencies. So Homebrew is what you'd see on a Mac as an optional package manager. So I guess, have you guys done any, I know this topic has come up in the Google groups several times, and people have kind of come up with some really wide-ranging set of requirements here. Have you guys given any serious thought to this, or am I the first person to actually start putting this on paper?
I think the optional dependencies have been in discussion for a while. I think since we're introducing the new resolver, basically dependency version V2 or whatever you call it. We have talked about that because when it came to dependency, and in this case constraint, is often or not, it means that you require it. And for the most of the use cases, you require something. That's why you put that a dependency. Even though from the context of a dependency, you can always say that I want this for sure, but for the other one, I may want it, I may not. It's not, should not be a blocking manner there. But at the same time, we haven't seen a particular use case since then until now on any team or any person specifically that actually want to have an optional dependency, or they actually need the optional dependency right away. And because the current operator model that we have is pretty much that if you need it, you need it. And normally or not, it's just basically a controller and, watching, reconciling certain, CR from a certain API, CRD, right, so to speak. And the concept of optional is not really applicable on the CRD side of way. That means it's there for you to use. If it's not there, then you can't really do anything. And if you query that API endpoint, you're probably going to get the error return because the API doesn't even exist because the CRD is not installed and so on. So far, I haven't heard any strong use case of requiring an optional dependency yet, even though it seems that will be something going to happen eventually, I hope, when the operator pattern to become more complex and more flesh out, so to speak.
Yep. Okay. So we have those use cases, and I'll try to describe them within this document when I get there. So we have, like, for example, we have these things called cloud packs, which are basically collections of operators, and we have some cloud packs that have 40, right, such operators in them. And depending on what the customer decides to use, they might not need 25 of those operators, right? So why would we bother installing all of that overhead if they're not even going to use the feature? So we call those things capabilities. And so we want the ability to dynamically provision those capabilities on demand when they're needed. And so I don't need to get into all the details of that, but I'll certainly describe that here. I just wanted to find out if you guys have already had some kind of spec kind of in the pipeline that I hadn't seen. I had not seen it as part of the new DEPI or the RuckPack API proposals yet.
I cannot speak for the other project that you just mentioned, DEPI and bundle API and stuff, because I'm not deeply involved into that. But the current project I'm involved in, which is the one I will talk about a little bit after you, is the cluster runtime constraint. The syntax of it allow you to specify optional, even though it's currently not in the proposal, but it's an option. That's how the syntax designed to be expandable to certain component, which in this case, the optional piece of it. We can talk about that when it came to it.
Okay. Yeah, I won't take a lot more of your time here. I more or less wanted to make sure I wasn't reinventing the wheel. And I guess I'll learn more about yours. I've read your EP like last week, and so at least I'm familiar with it. And I didn't see the optional piece of this particular part. But essentially, I wanted to. So the question I had is, there's kind of two ways to go about defining an optional dependency. So way one is I was thinking of adding an intent field to the dependency, the OLM package, right? So whether it's required, recommended, or optional. And then, so today everything is required, that's the default. Recommended says, hey, I will provision it if it's available. If it's not available, then I'm not going to provision it. And the optional is basically the other way around. It says, I'm not going to provision it even if it is available. And then, so they'll have to do it themselves. The advantage of having a dependency here at all is there's really the way I think of it anyway, the ones I know, and this is a question, is these are the main clients, the consumers of the dependency. So the dependency resolver itself. So the guy who's building the install plans, reconciling the subscriptions and all that stuff, right? So he's obviously looking at that information, feeding it into the stat solver. Then the provisioner itself, when it's installing things, uses this information, and these are tied together at least in OLM the way I understand it. And I'm starting to look at the code now, and I really don't completely understand it myself. Then there's these curated catalog collectors. So the new OPM alpha diff, right? So that guy is introspecting this information to determine like heads of channels, other related packages within catalogs and so forth, to be able to build subcatalogs, right? So that's why I call it curated catalog. And then related image collectors. So these are things that are collecting all of the images that are in use by a catalog, right? So those are using the the dependency, the deployment controller and the manager image, and it's also using the related images. So one of the reasons why I went down this road, right? So adding an intent to this is this didn't really break anybody. All these clients would still operate as if everything was required, because they would just ignore this field. I haven't tried this yet, so I don't know if that actually works, but I'm pretty sure these are just ignored, other fields in here. So to give us a way where at least all these collectors would still work as they are, because these are really not runtime things. These are kind of, I would say, infrastructure things, where these are runtime things. So I wanted to separate out the two different categories of catalogs to allow the old behavior to still work. So today we describe a lot of these dependencies today, and by enabling this feature and then having the dependency resolver all of a sudden understand what recommended means, would be okay. It would just stop provisioning those things. We should be fine. But then the other side of the thing is, well, no, we do have situation already where we're not declaring dependencies at all on some of these other operators. So I talked about foundational services. The way that works is that one operator will have a dependency on foundational services operator. It internally has about 15 other operators in it, and it doesn't describe that dependency through those other operators through OLM at all, right? They're all done through some other proprietary mechanism. So by doing it this way, then in proposal 2 here, so dependencies remains the way it is now, but we could separate them out. This is what Homebrew does, I think, if I remember right, is they basically create different dependency objects depending on what they are. And so if we did it this way, that would satisfy that use case where they would just be ignored by OLM until they started honoring those things. And then that particular case would continue to work. However, this would also be ignored by all of the air gap, the disconnected image mirroring stuff too. So that would no longer work. So I'm kind of leaning towards proposal 2 because it has more applicability to my particular use case, which I need to describe in here a little bit better. But it also has the problem where you can't build sophisticated relationships. Like, for example, the new compound dependency model, which we've been talking about for a long time, like ands and ors and stuff like that between these. It'd be hard to do that between these, but maybe that's okay because that simplifies the resolver. Anyway, so I just wanted to kind of just throw that out there and see if this is in line with what you guys have already been thinking. And what I'm going to do is I'm going to finish this part of the spec. So this is the spec part of the spec that describes the dependencies and then how these things would work. And then I'm going to have a separate one that talks about how this metadata could be used to dynamically provision things. Like, for example, maybe on the subscription, you have another field that says, hey, also provision, some other package, right? So however it's defined in the optional dependency section, provision that thing. Or if you have a GVK, go ahead and provision whatever provides that API, something like that. So I wanted to kind of divorce those two concepts. So really the question I had is, are there any other, make sure my question's up here. So are there any other consumers of that dependency information than what I've described? Are there any more I need to consider?
Yeah, so this might help drive some of this conversation as well. The one that I don't know was explicitly called out is the the actual projection step. So like when you actually, like today, the way it works right now, we have these index images with a database, right? And OPM knows how to unpack a bundle and then translate that into something that is defined as a set of properties, right? So like we have this sort of generic property system now in the database schema. And when we move to file-based catalog, similarly, we'll have sort of an arbitrary property field that includes dependency definition. So I would call out specifically anything that takes the bundle as input and translates into an index definition, which is, I think, separate from the runtime component of I already have the bundle, I'm installing it.
So isn't that kind of like isn't that the same logical code that's inside OPM alpha diff, or is it different?
The difference I want to call out is that there's a difference between I need to know how to look at the contents of a bundle and then pull the metadata out of it, and I need to translate the meaning of what these dependencies are into something that's consumable by the resolver.
Gotcha.
The reason why I think that's an important distinction to make is because I think as we're starting to build out a lot more of the bundle spec for especially new property types, I think that having an explicit schema for properties for dependencies might actually be something we want to pitch onto this, right? Like rather than have an explicit schema for dependencies.yaml, if we could fold that into, we just have a property definition, and one of those properties happens to be some different dependency types, that feels more like the direction that the bundle spec is going anyway.
Yeah, okay. So what do you call that? Do you call it the bundle to index projection code? Is that what you called it, or?
Yeah, I guess I don't know if we have like a specific name for it. I don't know if there's
Okay.
a better phrase. I might have to think about it. But yeah, that's kind of what I'm thinking is the code that knows how to translate dependencies.yaml into a property.
Yeah, okay.
Effectively, that's OPM registry / index add or OPM render, right? So registry and index add subcommands work and build SQLite databases, and OPM render takes a bundle image and writes out the equivalent file-based catalog.
Yeah, okay. Are there any other clients of that information that you can think of? Okay. Then, you know, the real huge gap in my knowledge right now, and I'm trying to I'm looking through the code to understand the relationship between, you know, how the where all the resolver does all of its work with all the generations and steps and all that kind of stuff. So I've coupled together, I've decoupled the code in my mind anyway from the dependency resolver who's trying to detect, hey, what do I need and where is it already present, versus, oh, it's not there, so I need to provision stuff. So I need to fill in those gaps, and those gaps are fill-inable, right? And I can provision those things. Is this the right abstraction to keep those two things separate?
So from OLM's perspective, it is useful to keep them separate. But like from an implementation perspective, the only thing that cares about dependencies is the first one, right? Like as soon as we do the resolution, we generate an install plan. That install plan just knows how to define the set of stuff that's going to end up getting installed. So at that point, we don't really need like the install plan controller doesn't really need to know anything about the context of the dependencies.
Well, the reason why I've got this in here is because there needs to be a decision. There's a difference between recommended and optional, right? So they do give the provisioner instructions on what to do, right? So if it's recommended, go ahead and provision it if it's available, versus if it's optional, don't provision it. Even
Right.
if it's available.
Right. But I guess the point is that that would be a constraint on the resolver either way, I think.
Gotcha. Okay. All right.
At some level, the translation is going to happen before then. We're not going to make a decision about what to install or not to install anywhere else.
Okay. So, okay. So then I think the other thing I had was, I'll ignore this for the time being. I'm curious about the next one, and I need to think about this in the context of what you were talking about with the OPM, you know, the property projection, all that kind of stuff, because that might help me decide how this is going to work. And I think once I understand a little bit more how the resolver actually gets that information, then that could help me decide where that should live. And of course, the next one that we talk about will help that as well. Especially with compound dependencies and how those things actually pan out. So just, I guess the last thing is, am I way off target? Should I continue down this road? Would you guys be willing to look at this after I get this kind of filled up over the next week or so? Or do you guys, have you guys talked about this, and even if I come up with a strong use case, you don't think it's worth it? I just want to know if I'm wasting my time.
Yeah, so I think I asked some maybe open questions about the difference between the actually optional and recommended dependencies spec, especially in the context of how that would work on cluster at resolution time. But like minus that, I'm not sure I have any big reservations about anything else that's sort of described here. Like I think this is a fairly reasonable proposal.
Okay.
Yeah, so from my perspective here, I think this is just your first, I guess, initial draft of what you have been thinking about. And I feel like, you know, it's nothing wrong with continue going down that path and, you know, add more context, add more use cases, add more example on what actually you mean by optional, how is that going to work, how you envision that to work, and recommended, for example, as well. That concept is not entirely clear yet. Optional is more, you know, a little bit clearer, but recommended, what does that mean? And you can put example with more context on how you envision the behavior would like, and put it up, and we will see how so that gonna work with the resolver, and then we can go from there. Because I feel like any revenue is value, regardless what's the eventual outcome.
Gotcha. All right, perfect. Yeah, I don't have any of this filled in yet, and that's my next step. I just wanted to, I've been kind of rushing through this week, and I just wanted to throw it in front of you and just make sure I wasn't missing anything. Are there any, you guys are also experts in a lot of these things. Are there other package managers that you think I should look at that you've used as a template for how you guys have designed dependency management in OLM that I'm missing here?
I think for optional dependencies, you have most of the ones that I know of that have that. But you might check Yarn and what's the Java one? OSGI. Is that right?
Oh yeah, I should have known OSGI. I use that one all the
Both
time.
of those are a little more like the property stuff that we have.
Okay, perfect. All right, that's all I had. I just wanted to throw this in front of you and just see what stuck, and I'll take this forward to the next level, and probably next time you'll see it, you'll see it as an EP.
Absolutely, thank you, Chris. So hopefully, actually, now I'm thinking about this. The next piece I'm going to talk about, hopefully it may aligning with what you're trying to do a little bit, and then we can go from there actually. So hopefully the next discussion will be helpful for you. Let me see if I can share screen here. Just give me 1 second. It's the problem with there way too many screen. All right. right. I think everyone see my screen now. I hope.
Yep, I can see it.
All right, wonderful. So I just would like to talk a little bit about the cluster runtime constraint proposal that I have up on the enhancement repo. It's only been up for about a couple of weeks, so I know some people may not actually haven't seen it yet. So I recommend you guys to take a look into it. And even though it's only have quite a few comments there and some discussion going on already, which is really encouraging. And I recommend you guys to continue put in feedback. And I want to say one thing that, is the enhancement discussion is not always about, the people from outside are asking me question and I'm the one answering the question. This can be an interactive multiple discussion on the comment itself that other people may want to jam in on the answer, not just me who's the one doing the enhancement in the first place. So I have seen people already doing that, which is always great. So I recommend doing the same thing for you, not just review the enhancement, but also see the comments from other people and to see if it's aligning with what you're thinking or what your feedback would be for that specific comment as well, not just for me. So I just want to go over this real quick. So this proposal is about providing basically a solution for the fact that on the cluster specifically, we having certain constraints that associate with that specific cluster that actually matter to the operator when it gets installed in the cluster. For example, in the most common, easier way of thinking that a Kubernetes cluster obviously is going to be at a certain version. And at that specific version, it having certain API that are available to be used, or certain capacity feature that are available to be used. And an operator may require or may need a certain feature to be available on a specific Kubernetes version to be able to install, and vice versa as well, that the cluster itself want to prevent certain operator to be installed because certain restriction that the cluster want to impose into the operator itself. So this proposal is about discussing a solution that allow you to specify certain constraint on the cluster itself, even though in the broad sense of thing, it's not necessarily need to be just a cluster specific thing. It can be a bundle specific thing as well, or operator specific thing as well. And the goal is basically allow the cluster admin, basically whoever, controlling the cluster, to specify certain restrictions, certain constraints to prevent certain operator or certain bundle to be installed on a cluster that potentially not functioning correctly or not even installable in the first place. And the second piece about certain constraint that been specified, basically this is in the opposite direction. That for the operator author themselves to basically specify certain constraint to depend on all the operator property, or depend on the cluster property itself as well. So that is something that potentially helpful for the operator to specify what it needed in the specific cluster. And also in the similar concept with GVK and packet dependency, depending other operator property as well. If it's offered certain API and so on and so on. And so the proposal, at least I try to. This is only the first iteration of proposal, so there's a lot of things I'm trying to scale it down to make it a little bit simpler at first and let the conversation flowing, and we can potentially expand it to be a little bigger, a bit more, inclusive in the next iteration of that. So the current concept of cluster constraint is basically encapsulating in a config map, which is the basic data store that I'm thinking about at this specific moment. And as you can see here, the config map is, you guys probably have seen that many times before. So it is basically config map and the data section here, basically where the spec is. And then you can basically list a bunch of field and valuable, key pair to basically having some information on that specific config map. And map also was basically a data this with a property here. The naming convention is not, finalized yet, but I'm called a property at this moment. And then this basically is a list of constraints that specifically for this cluster. And that for each of the constraint, the pro syntax will basically just a JSON blob that you guys see here. That basically telling what a type of constraint it is. And in this case, basically constraint. And the value blob here, which is actually the more important piece of the JSON blob here, that it involving certain information. I guess the first piece is the source here. Basically, that is, in all the type of constraint you can think is basically the value where the information mainly is. And the evaluator here, this I want to mention real quick, is basically the library that I intended to use here, which is basically a several library. It's evaluation expression evaluation library, where you can basically having an expression that will be evaluated later, and that expression will be evaluated again a set of data essentially, and depending on the information on that set of data and your expression, it will return the true or false depending on it's actually meeting that expression, that requirement on that expression or not. And it's the project that has been used in other open source project as well, including I think STL using it. I think gRPC also using Servo for some of the validation as well. So it's been up and up and pretty popular as well. So you want to check it out. I think I did link the Servo library somewhere on the enhancement. So if you take a look at a later time. And this specific blob of evaluator here, which is the ID with the cell, which is basically a short for Servo. But the intention here is that Servo may be the first initial supported library of expression evaluation library that we're using, but it may not be the only one. And potentially we may support other library, other languages out there that also doing a similar thing, having an expression and allow you to evaluate it at a later time. And the reason why we're using this is the fact that so far for OLM specifically, own up the syntax and evaluation for certain dependency in this context or constraint context, basically pretty, I would say, concrete in a way that you see the package dependency constraint that having, the package name and the version. And for the GVK, they had a GVK information and stuff like that. And all of that is basically hard-coded in the OLM code base. And we would like to basically having at least an attempt, so to speak, to something a bit more generic. That how do you do the comparison? How do you do the evaluation of a specific information? It's not just some specific hard-coded function that we build up by ourselves, and you basically the one knowing it in advance or knowing it via documentation and had to basically doing the exact same thing. And we would like to offer a way to using certain library that you can, build your own expression and basing on a data set that you know in advance, and make sure that the cap condition will be met basing on the expression that you build. And I think several library can actually offer you to doing so, and potentially will be other library out there. So the ID field that you see here is for that. And it can be, something else in the future. And the reason we're using a struct here, so to speak, with the ID is that potentially we're having more field in this evaluator struct to basically specify something further for that specific library or specific languages as well. Maybe imported, function somewhere for you to select, oh, I want this specific feature of that library or that languages or something like that. So we don't want to basically box ourselves here that only having an ID to tell you this what library you're using, but also having more customizable option later on. So that's why we decided to be a struct here for that specific reason. And in this specific case, for the source, basically that will be a several expression. In this case, this is an example here. What this means is essentially imagine the property here, basically a map, and this dot exist function basically go through the map and checking for every single item in that map to finding the type equal the type, basically a field, basically a key in that for every single entry to finding the one that matching this certified. This is an example. It's not real in by any means, but you can imagine how it goes. So you're having a data set, which is the map of many different property item, not necessarily property, but in this case for resolve purpose, I'm using the word property, but it can be anything. So you can basically go through that and evaluating it. And if it exists, you return true. If it doesn't exist, obviously return false. And the action here, piece here is a little bit more, I would say a little bit more obey here. In fact, action is meaning for the resolver, the OLM resolver. That in this specific case, the idea here is to require, meaning it's similar to what I think Chris already said, that this specific constraint is a required requirement. So it need an operator somewhere need to meet this requirement, or it's basically no go essentially. And the reason why we have an action here, because I can imagine the action can be extendable in the future. For example, for OLM require obviously a pretty common action here that pretty much every single package GVK dependency that you can see here is a required, right? So when an operator specify a package dependency, that means we need to have it this satisfied in order to get this operator installed in the cluster. So that's a pretty common concept there, but it can be something further as well, like another common piece in OLM is basically conflict, meaning that it's required this specific requirement, but only one of them basically satisfy this requirement. There should not be more than one of them. If there are more than one of them, mean there's a conflict, meaning that one of them, there are way too many of them satisfy this specific constraint, for example, and there should be only one of them. And you can think similar fashion, it can be something further than that. Even though in the techno speaking here, that the way the constraint work in OLM, that even though if you specify two different dependencies, it can resolve into only one operator which satisfies both dependencies, or it can resolve into two different operators that each one of them satisfy the individual dependency there. So that why I think Chris mentioned earlier on his presentation as well, that there's no compile constraint here yet. And this several library allow you to do so. And you can see here, I would probably can having a link somewhere I can pull up. Essentially, this sort function here, this the entire piece of the property dot exist blah blah until the end. It's one condition. You can do something after that. Let's see, I can load. Sorry, it's switching around. Can you see my HackMD screen?
Yeah.
Okay, wonderful. So you can imagine the several language itself allow you to do something similar. Let's say like this is an AND operator, right? Property, blah, 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 something like that. So you can imagine that in this specific evaluation, you can specify more than just one condition. And depending on what's the operator, so to speak, in the language term you use here, this can be a compound and an OR relationship between the next requirement that you specify here, for example. So that is basically virtually presenting the concept of compile constraint, right? So you can imagine this specific condition first is some GVK evaluation, and this is an OR, but you do and here, and having another expression condition to basically also require this packet to having certain GVK constraint as well. So you can imagine that way. And that will be an AND relationship between two different properties that you need to be satisfied. So that is another helpful, I guess, feature that this specific library and this specific concept proposal can offer as well. And on that similar, sorry, jumping around too much. So in the similar concept in the action piece here, even though this requirement action here is basically among the property itself, but at the same time you can put another field down below, name, I don't know, get requirement add a key and put the optional there, meaning that this specific constraint can be an optional constraint, for example. So that also basically what Chris was talking early on as well about something that optional. You can actually put this constraint to be optional in that way, meaning that if it exists, we will resolve it. If it doesn't exist, that's not a big deal. We can go ahead with that.
Can I just ask a couple questions?
Sure.
There you go. So the name of the config map you've called OLM runtime constraints, but really
Yes.
what it is, it's a bundle constraint policy. Isn't that really what
Yes,
that
in
is?
certain sense. Yes. You can specify it that way. You can make sure this is certain policy that you apply on the cluster, but it can also presenting a possibility for you to include certain property of the cluster instance as well. Because for example, this type doesn't need to be OLM.constraint, for example. It can be OLM.property or whatever the name that you can think of, OLM.Kubernetes version, for example. And a value here, you can using the entire, you don't have to use this thing. Yeah.
Yes, that's where I'm getting confused, because these are constraints that you're applying globally, right, for the whole cluster in this particular use case. And so these are constraints that you're going to provide a policy cluster-wide, which is going to basically say this bundle has to have these properties in order for me to provision them. Right. So there's no runtime constraint at all there. These are all static constraints that are part of the bundle. The inverse of that is how do I express constraints in the bundle that are based on runtime characteristics of the cluster? So those are constants, or at least temporary, transitive constants that would have to be expressed somehow. So it seems like they're two separate things that you're maybe you're trying to express two separate concepts in the same spec.
So Chris, I think for your original question I think I understood what you're trying to say, and the name of the config map is confusing. I understand that. Does it help to think of those as, instead of OLM runtime constraints, if you think of that as cluster values, does that help in clarifying? So this config map is basically providing the values for the on cluster. What OS do you have? What architecture do you have that needs to be matched with the bundle constraints? Does that help clarify that?
That's not at all what I got out of this. So if that's really what this is, so are you saying that you can, in your source, you can actually map runtime values with statically defined values in the bundle? Is that what you're saying? So you can kind of marry the two at this level?
Yeah. So first of all, thank you, Nick, for speaking. I'm saying here, this is the syntax for the constraint. I guess I understand what you're saying here. The fact that this naming maybe will be confusing. It can be, OOM something, configuration or whatever. And because the reason I'm saying here, specifically for the constraint piece, is what it's going to look like, but it doesn't have to be the only type of value you can put in here, if you know what I mean. You can basically give the type and a value that does not require this specifically evaluation. It can be just a runtime information that the other bundle can depend on. You see what I'm saying here? This is just one type of property, so to speak.
Yeah, I think it might be helpful just to have more examples of runtime constraints versus static constraints that you're using as a global policy.
Yeah,
so for this specific, go ahead. I'm sorry.
No, I was just going to say, like, it helps me to think about this more like, so this thing represents a virtual, this config map represents like a virtual bundle, and a bundle can have properties and constraints. And when you create this config map, it is effectively a bundle to the resolver, a bundle that always must be in the resolved output. So all of its constraints need to apply. All of its properties are things that bundles can actively depend on. So that's where the runtime part comes in, that at runtime, I can add this static list of bundles, this static set of properties and constraints that are injected into every resolution.
So you're saying this is like an overlay onto every single bundle?
That's a little bit different. This is like a virtual bundle that gets injected into every runtime. There is the concept of like a negation constraint that's like a constraint that acts on all bundles. All bundles must or must not. Whereas like a normal, like typical constraint so far has been, I need at least one bundle that does this thing.
Yeah, I don't understand it all, but that's okay.
Oh, sorry.
No, that's fine.
Well, the only thing I'm after is that from a customer perspective, is anybody going to ever understand that? Or is this really going to be really low level and then you're going to have some kind of abstraction above this that shields the customer from this?
I think eventually the idea is that this is backs a bundle resource from Ruckpack or something like that. And like there is a bundle for the cluster that is always like instantiated on the cluster and lives there and has all of these like constraints in it. And this is, I guess, just the storage mechanism for the data in that.
Okay, so you're saying this is a bundle, a virtual bundle that represents the runtime of the cluster.
Yeah.
Yes.
Gotcha.
Okay,
Gotcha.
so thank you, Nick, for talking. There's certain concept about resolver is a little bit difficult to understand, but I think I just explained down below about runtime, ignoring this runtime dependency. This is the resolution piece here, the runtime constraint resolution. Is that where it is? I think hopefully I put it there. So what Nick meaning is that you remember how it is for the resolution on OM that every single thing in the same namespace get resolved together, right? So imagine then existing operator on the namespace already. When you installing a new operator in that namespace, the new one and the existing one are both input into resolver. You see what I'm saying here? So the new operator, when it gets resolved, it must not do something that conflicting with what the existing operator require or something along that line. So you can imagine this config map being converted, virtually, so to speak, into an existing operator in that namespace already, with certain property, certain constraint inside it.
Starting to get it.
Does that make sense? I'm sorry, who was saying something?
I was starting to, but Chris, if you have more follow-ups, I can wait.
I was just confirming. I'm starting to finally grok what you're talking about. Thank you.
Yeah, so that exactly what Nick was talking about in terms of virtual, what the virtual mean. It's, you can just think it's existing operator in that namespace. And obviously in this specific concept, it's a global operator, if you know what I mean. That means it's actually in every single namespace. So that way is an input to the resolver. I know it's been wonderful discussion. I run out a bit of time, but go ahead, Joe.
I just wanted to ask if we've thought about, and I put a comment in the EP about this, but this aspect of the design strikes me as potentially a little bit fragile if the cluster runtime virtual bundle is just a sibling, because it seems like I could really easily kind of, whether I intended to or not, route around cluster constraints by saying like, oh, I'll just install another bundle that meets the constraint that I want in this namespace, or that specifies a constraint that will allow more bundles to be passed through the resolver. Am I making sense? I'll use a concrete example. Yeah.
I was just going to ask, I think correct me if I'm wrong, I think that's intentional, right? We need some mechanism of overriding these.
I mean, yeah. So what Joe says is literally how you do the consideration in the first place, right? For example, if you have a bundle requires another package somewhere that doesn't exist in any catalog source, you can actually installing the dependent piece of it in the cluster. So this main operator can get installed.
I guess like my concrete
Yeah.
example is I might have a cluster bundle that says property equals version 1.22. And I really want to get my 1.21 thing, or I want to get my 1.23 thing installed. The cluster constraint says I can't do it. So what I'm going to do instead is I'm just going to install another bundle that has a property that says 123. And now all of a sudden the resolver will say, okay, yep, there's something in here that's installed. It says 123, your constraint matches. You can install yourself now. Is that okay?
Sure. It's
Yeah,
for the operator, right?
sure. Because you should remember one thing, that OM doesn't control the contents that available on the cluster. If you having that specific operator that you're talking about available in one of the catalog source, then you feel free to do so.
So I think it's
Oh,
To me,
Go
it
ahead.
seems like like this use case is about cluster policy, but like the example I gave is basically like a user can violate that cluster policy. So I'm just concerned that like the design that we're building doesn't actually meet, if we're looking for cluster policy enforcement, like this doesn't do that really.
I'm not sure how we started using the word policy. I don't know if that is the intent, but I think this touches upon one of Chris's original question as to what does it look like from the customer's perspective. And what I thought was, and probably this will be helpful if we have it in the enhancement as examples, is if I'm an operator author and I want my bundle to only be installed on a cluster that has a particular architecture or that has a cube version greater than 120 only. So that's when I include this dependency in my bundle, and the config map or whatever provides me this value has that value for me. And then the dependency resolver checks, yep, this cluster has the version that you want, so that you can install, or no, you cannot install. That's what it looks like from the customer's perspective, and the customer being the operator author for us.
Correct. Yeah, I wouldn't. I think Nick having a good point. I wouldn't say it's a policy in here because it's no, because the cluster admin or certificate, the people who did wrote this kind of expression and constraint can do so much, but it's also depending on the bundle and the operator author side to basically having certain identifier, in this case property, for us to tell if this specific operator is actually meeting certain requirements. If you skip all of that, then obviously we cannot tell because we had no variable data to basically comparing or do certain operation on.
And you can frame this as a policy too, right? So for example, a cluster admin can come in and say, I only want any bundle that requires cube 122 to install on my cluster. Anything that requires anything less than that should not be able to should not be installable on my cluster. So then that is the kind of policy enforcement that you can think about in that way, but that is on the cluster.
But my point is that if you have catalog source write access, then you can install new virtual bundles that define whatever constraints and properties you want. That will let you then further install more bundles that violate the original constraints.
Yeah.
That's the cluster admin.
So the one of the properties that saves us is that if a cluster admin adds a constraint before a user does, then this is the thing that's already installed. And in short of an update edge, which I suppose if we may be able to in some future resolve updates to these things, maybe it would still be fragile for users. But there are also some other things we can do to prevent that sort of tampering. Like we can one option is like signing of property sets or constraint sets.
I'd even go further to say that the purpose isn't policy enforcement for cluster constraints.
I just think like reasonably someone's going to ask for that.
So if they do, then this has to be decoupled from cluster constraints itself. There has to be some other mechanism that is not cluster constraints that's enforcing this policy.
Yeah, that's why I was trying to making this argument in the chat that like this system is more about defining what the constraints are and defining a system where you can use those constraints in a way that solves your problem. That's like there's a difference between like the what is the constraints and how do they work and the enforcement of policy of can you modify constraints, right? Like that's no different than the difference between a service account and RBAC, right?
Yep, I agree.
Yeah, to me, it's like the vector of arbitrary bundles, at least like obfuscates the policy around who can create and not create. Because at the end of the day, it ends up being like who can create catalog sources, right?
Is that really a problem to solve, like cluster policy?
Well, I guess I mean like
No.
maybe it's not a yeah, maybe that is a cluster policy, but it's not obvious, I guess, that that's a entry point into changing constraints necessarily.
So is this the
cluster constraints?
So is the feedback, or is like the takeaway from this conversation that there needs to be like a section in this enhancement that goes over like its use as a cluster constraint and bad actors and options for avoiding sort of duplicitous constraints being added from sources that aren't the cluster admin, like that. That sounds like, yeah, go ahead.
Yeah, I think that would cover it. Yeah.
I'd argue for a statement in the out of scope section that says that enforcing cluster policy is out of scope for this work.
Yeah, definitely. We can having a section to discussing about how this constraint be applied to cluster and how is that relevant to the concept that we can basically having a workaround on certain specific piece of constraint if we need to, which is to me that is rather obvious situation here. For example, even if you require certain constraint on the bundle, for example, if that bundle doesn't have the property to tell you that it needs something or not, then you cannot basically enforcing that specific constraint either. So there must be understanding between this specifically of cluster information and the bundle on the operator side as well, because it's just like you speaking the same language. For example, you need to understand language to be able to understand the other. If you don't understand the language, then there's nothing we can do. So that's to me how I'm envisioning it. But yeah, we can possibly having a discussion on that and add a section there to clarify a few things that this specific enhancement is not going to touch and probably going to require certain further development to get that thing figured out. I see a couple people raising their hand. I don't know how to see that on this UI. Feel free to just speak up. I think Evan was the one raising hand first. Go ahead, Evan.
Yeah, I kind of wanted to talk about the enhancement as a whole because I think it looks pretty good, but there's two separate things going on. One is the ability to specify constraints in cell language, which is really cool. And the other one is the ability to specify these constraints over everything for the entire cluster. And those seem like really separate things. And there's a whole separate feature that's missing in OLM of compound constraints that the cell constraint solves. And there's just kind of like a little note that I wouldn't even call them, quote unquote runtime constraints, right? That's just a normal dependency declaration, but it's using the cell language. So I don't know if it makes sense, especially since seeing how contentious the the policy discussion is it would make sense to split this into two. One that's like just supports cell in constraints. And then the other one is how we're going to do this for the cluster. Does that make sense?
I'm fully on board with that because Evan, if you remember, the declarative config also started up and the queue, implementing queue or declarative config with queue was also mixed together, and then we had to separate that out. So this reminds me of that. So I'm fully on board with that idea.
Yeah, absolutely. I can see the reason behind it. Hopefully everyone can hear me. I'm so lost on this Zoom UI. I don't know where the control panel anymore. Yeah, so we can certainly put a few things in the app scope to make it clear that there's certain piece of information, certain piece of, I guess, the discussion that not going to be addressed right away with this enhancement, and that can be a separate feature on its own. But at the same time, I guess this is the first time I'm presenting this to a broad audience. So I would love to just let the conversation flow and let the discussion flow and see where our imagination, our thought can get us to certain, certain basically area that we have been discussing so far. So yeah, so I just want to let it open there. And anyone, we don't have time here, so I don't want to get this thing go too long. It seems this has been a wonderful conversation, and I feel like the people are having a lot of thought about a lot of different areas. So why don't we just put a comment there, and discussion there, and basing on that, we can narrow it down, put a few things in the app scope, and potentially splitting this thing into multiple smaller things that we can discuss further. This only been up for about 2 weeks, so there's still a lot of things to discuss about, still a lot of things to explore, so to speak here. And it has been wonderful to hear you guys so interested on this, and feel free to just comment there, and we can continue this conversation in the next meeting when we even having more input into discussion. That would be nice. That's all good. All right then. We have time here, so I just want to say thank you everyone for joining. This has been a wonderful discussion, and I'm looking forward to the further offline discussion that we're going to having in this specific topic, and also for what Chris presented earlier on as well on his specific enhancement. So Chris, if you can put that up and having further information, feel free to share with the entire group on on Slack or in the Google group as well. And feel free to put the next item on the agenda for the next meeting if you want to discuss further, and I would do the same. And thank you everyone for joining, and we'll see you guys in the next meeting. See ya. Bye.